Welcome to you all. In today's lecture, let's learn about separation axioms in topology. I am Dr. P. Santhi, Assistant Professor of Mathematics, the Standard Fireworks Rajaratnam College for Women, Sivagasi. In today's lecture, let's learn about the main learning objective of this lecture is basic concept about topology, and we learn about some of the separation concepts like T0, T1, T2, T3, T4, and also about regular space, normal space. Finally, let's learn about its properties and its relationship. Let's move on to the main concept. What is topology? Topology is concerned with the properties of space that are preserved under continuous deformations such as stretching and bending but not tearing or gluing. So that means it is considered under a flexible material. So in the simple example here is, in the topologically, triangle and the rectangle present here are equivalent, but mathematically they are not equivalent. Because if you just pull on the parts of the circle to make corners and then straighten the sides to change a circle into a rectangle. So we can easily convert a triangle format into a rectangle without any stretching or gluing. That's why these are topologically equivalent objects. Next, the mathematical definition of topology is, let X be a non-empty set and tau be a collection of a subset of X, then tau is called a topology on X if it satisfies the following four conditions. One is empty set must be a member, whole set X must be a member, and finite intersection must be a member, and also arbitrary union of open sets belongs to tau. We call the pair X and tau is called a topological space. Now let's learn about the different separation axioms. First one, T0. For T0, for any 2 points X and Y in X, there is an open set U which contains only X but not Y. So this kind of formation is possible in a topology. This kind of space is called the T0 separation axioms. Next one is T1 separation axiom or pressure space. That is, for any 2 points X and Y, distinct points X and Y in X, there exist two open sets U and V such that X is a member in U and Y is not in U. Similarly, Y in V but X is not in V. So it may, the two open sets U and may be overlapping, but each single open set should not contain both the points. T2 separation axiom or Hausdorff space. Next one. So this is another interesting separation axiom. In this case, for any two distinct points X and Y, there exist two disjoint open sets U and V such that U contains only X and V contains only Y. Next, T2 half separation axioms, or this is called a special name horizon space. So for this case, any two distinct points can be separated by closed neighborhoods. In previous cases, we considered only open set. Here, two distinct points X and Y are separated by two disjoint closed sets. Then it is called T2 half space. And then next one, regular space. For this case, we consider one closed set on a single point. Then in this case, there exist two open sets, disjoint open sets U and V, such that U contains X and V contains F. Next one is T3 separation axioms. So T3 separation axiom must satisfy T1 space and also a regular separation axiom condition. If it satisfies both, then it is called T3 separation axiom. Next concept is normal space. Normal space, for that we consider two closed sets C and D. Then there exist two disjoint open sets U and V such that U contains C and V contain D. This kind of concept is called normal space. And then next one, T4 separation axiom. This is nothing but a T1 space along with the normal space, that is called T4 space. Now finally let's discuss about its relationship. So here the T0, T1, T2, T3, T4 relationships are given here. So it is explicitly and clearly explained in the next slide. See here you consider, we know the basic concept metric space. So outer line indicates the topological space. So its immediate subspace is T1 space, and then its next interior subspaces are given. Finally, the relationship between all the separation axioms are clearly explained in this diagram. The inner subspace is a metric space, outer subspace is a topology. All the related separation axioms are given here. And thank you all.